Wētā FX is one of the entertainment industry's leading visual effects houses, having won 7 Academy Awards and 3 Emmys, most recently for HBO's The Last of Us series. While working on Avatar: The Way of Water, Wētā FX was met with a unique challenge. They did not have enough available computing power with their on-premises workflow to render their high volume of effects and deliver their portion of the movie on time. That's when they turned to AWS to try something they'd never done before, integrating the cloud into their workflow at scale. Join our solutions builders as we go all in on burst rendering in the cloud with Wētā FX. So what was it about Avatar 2 that made you think we're going to have to do something a little bit differently? And how did that bring you to AWS?
Avatar 2 is a big film. Some people think it's kind of like a flat line. If you're just working, you delivered shot 1, then you deliver shot 2. No, it basically goes as this thing where you're going along and kind of growing, and all of a sudden there's Mount Everest that you have to climb, and then you're finished with the show. The thing that brought us to AWS is during the pandemic, New Zealand was quite lucky during some of that, but one of the things where we were unlucky was getting hardware in. And we had planned to purchase another row of render wall, and we were not able to source that, and so it's like, okay, we need to be creative about different render solutions to manage that Mount Everest of render.
Well, that's an interesting challenge, especially given the supply chain constraints that happened during that time frame. Maybe we can talk a little bit about the architecture that you were able to drive in working with the AWS team, both from the service perspective and the solutions architects.
One of the things that's been going around the whole of the industry, right, is they're all about bringing compute to data. Well, our data is in New Zealand. If we couldn't ship the compute in, how are we going to bring the compute to the data, right? We just sort of flipped that around and try to figure out how we were going to send data to the compute. And so we had to sort of find creative ways of managing that automatic data transfer. The team really wanted to start to focus and embrace the infrastructure as code kind of concept. That was another thing that the AWS team really helped us evolve our thinking in terms of what it means to have infrastructure as code.
So can you tell me a little bit about what it was like to build the render farm that you were needing?
We have a piece of render software that we call Plow. Plow's the farm. I suppose there's
I was going to say, I come out of agriculture. That was perfect.
Right. On an on-prem render farm, you have the machines are all yours all the time. The team built a thing we call Plowed, which helped us manage the scaling to EC2 instances, right? So we could, as we had more demand, we could turn them on. As we had less demand, we could turn them off.
So Plowed is Plow for the cloud?
Yes.
If I'm guessing how they mash together.
Yeah.
I like that.
Yeah. So we were actually running primary orchestration engine, can manage multiple clusters, and we already sort of had that. And so this was just enabling and managing, okay, now please run this job on this machine.
Then you could point those to any region where you needed capacity based on what the actual job required?
We thought more of regions as how we were going to get the most compute we could. For us to go to Sydney, it's not too bad. It's 27 milliseconds or something like that. And it was actually relatively fine. We didn't have any scalability problems per se. Once we started going to places like Oregon, but then there was also access patterns, and this is where having the code to your applications actually really helps, where we could actually we had to change some of the way render software read frames such that we could read them differently, if you will, or ingest data differently, right? And making sure that you're minimizing the number of network operations you're doing, basically, to manage that latency.
Exactly, and you're never done. There's always things that you're going to look back at and decide you can improve on. Can you tell me a little bit about the unique way that you have approached caching? We often get asked questions of how does Wētā do this on AWS? And so I'd love to hear what you're willing to share with others.
We had, I guess, a few tiers of cache. We had one that was sort of a standard cache for caching program binaries, right? Different types of renders will actually use different versions of software and these sorts of things. We have different classes of storage for different types of files. And we actually did the same thing for caching, right? Where we had different classes of caches, because the access patterns for different things happen differently. We had different sizes of machines, actually, in terms of numbers of threads and how many connections they could have back to the mothership.
Yeah, I think that's a great way of describing that, is being able to say, how often do I need to be able to get to this specific thing in terms of storage? How long do I need to retain it for you from a caching perspective? Did you match your tiering strategy, or was it a multi-tier strategy that was differentiated between storage and caching?
We tried overlay FS, and that was kind of too slow.
Yep.
And then we ended up using Union FS so that it still looked like a particular render node was on our render wall in a sense, except for outputs would go to one location and inputs would come from a different location, right? And so there was a whole series of different filing systems that we used for writing out, and then had an automatic synchronization system to, once a render finished, to bring the files back.
You've worked with AWS for a couple of years now. You've worked on some more recent projects. Can I name drop a few?
Sure.
Last of Us, Guardian of the Galaxy 3.
Yep.
What are some of the lessons learned that you'd be willing to share?
The renders that we did for Avatar 2 it was at a very large scale. That's something that isn't sustainable for every type of show. One of the things we've spent amount of time working on is making it more efficient to sort of stand up a show and tear it down, right? A lot of automation around setup and streamlining and making more efficient the processes. So I don't think we've changed radically what we're doing, but certainly have worked on honing how we do it. One of the things we've discovered is it's really handy to put a bunch of renders out on the cloud, and then when you're using Spot instances, they get interrupted. And when you have a show delivery and you get an interruption, like one frame is dropped, you're like, oh, crap. We learned at the end, but have refined and is the practice of submit that out. But when you have an actual delivery that's due, bring it back such that if you do get if it happens to finish, great, you won. If you didn't, you've brought the render back and you can run it locally. We've sort of learned how to balance our resource usage much better between private cloud on-prem and public cloud, if you will.
Yeah, that's a great way of describing kind of that hybrid cloud approach of how you're able to use Spot-based instances to expand your capacity really quickly, but also have that disaster recovery availability based on the project timelines that you need. Very neat. Wētā FX has built one of the first hybrid caching workflows that works at scale by working with AWS. With this new approach, Wētā is bringing more efficiency and creative flexibility to their award-winning visual effects.